opposite direction. Force of friction is acting toward the center of the circular path. Understand? In this case, the body moves in a circular path in a curved road. At that instant, a force of friction is created. Force of friction will provide for the centripetal force. Centripetal force is actually cannot come down from the sky, but centripetal force is a converted force. Which is converted to centripetal force in this case? Force of friction of the tire and the floor will create necessary centripetal force. So centripetal force is provided by force of friction. So we can write in this case R is equal to R balances mg we can write. That means force of reaction balances mg we can write. Again what? F uh, F balances mv square by R. F is equal to mv square divided by mv square divided by R. That means the force of friction produces what? Mv square by R. Force of friction produces the or provides for the centripetal force. But everybody knows that. But everybody knows that F is equal to mu into R. F is equal to mu into R. Already studied, right? F by R is equal to mu. Force of friction and normal reaction, the ratio is equal to coefficient of friction. Already taught to you, right? Now, but R is equal to mg. Therefore, F is equal to mu mg also I can write. So this is equation number one, this is equation number two. Equation number two can be as equal to equation two. Equation two can be written as what? Mu mg is equal to mv square divided by R. Am I correct? Therefore, this m and m cancel, and v square by r is equal to mu g. V square by r is equal to mu g. I can write v square by r is equal to mu into g because m cancelled. Therefore, v square is equal to mu r g, where r is the radius of the curve or circular path. Every curve is a part of a circular path only. Therefore, v is equal to root of mu r g. I can write. Most of the time it is mu s r g it is written, right? I can write mu s also because at every curve, when a vehicle comes with a speed and enter into the curve, its speed is reduced considerably. Right? Normal speed and the speed of the curve, when we consider the speed of the curve is very much less than the normal speed on a straight road. So that is why that the body can be more or less at rest. We can because reduce the speed. That is why it is written as mu s r g we can write. So for a safest negotiation, the velocity at the curve must not be greater than mu s r g. It must be less than or equal to, for safest negotiation, the velocity of a body at a curved circular path must be less than or equal to mu s r g. That should not be greater than mu s r g. If the value of velocity is greater than mu s r g, right? Mu s r g, mu s is there between the floor and the tire, the force of friction, the coefficient of friction can be calculated. Radius is also there, right? Radius of circular path is there, acceleration gravity is g. This is calculated. That calculated value you must remember, right? And your velocity also you must see what velocity. Accordingly, as the curve and its radius at that particular point, a speed is actually calculated for every vehicle to negotiate safely. But if your velocity is greater than mu s r g, then you will surely skip. So safest velocity negotiate a curved level road is given by v is less than or equal to square root of mu s r g. Mu s is the coefficient of friction between the road and the tire, and r is the radius of the circular path, and g is the acceleration due to gravity. So this is about a level road. So level road, there are several questions also given there. All these questions also you will see. Problems are explained in the book. So many simple problems are there. Actually, circular motion I have already said in the two-dimensional motion. So it is easier. right? I am feeling very easy because the part has already been completed then, right? Okay. This is, I think you are able to note down all these things very clearly. You can note down the safest velocity, all this. Now I am going to explain what is a banked road, banking of roads, banking of roads, and banking means at heavy roads, that just like national highways and all, at the sharp curved places means circular curved places. The one part of the road is higher than the other part of the road. Inner part is lower and the outer part is higher. This is what is called banking. So there is an angle between the inner part and the outer part. Outer part is made made higher in level than the inner part of the road. This is what is called banking. By banking roads, it is easy to negotiate, and also without reducing the speed much, the vehicles can negotiate a banked road. So banked roads means suppose so a lot of what you call uh, fuel can be saved, and also tear and wear of tires can also be uh, um, uh, saved from this way, right? We can avoid a much tear and wear of tire, because in level roads, when you are suppose you are coming with a very high speed in the level road and reaching a curved part, you have to put the brakes all at a sudden, right? So with the brakes, when you negotiate the curve, a lot of problems there come up on the tire. That means wear and tear may take place. And also, once you reduce the speed, again you have to change the gear and all, first gear, again second gear, third gear, etc. We have to again exchange gear. So gear exchanging means involve a large amount of fuel consumption, right? Fuel consumption. So this is a very big problem. That is why in heavy roads, but in if the roads are not heavy, then no problem. Level roads are possible. But national highways and so many vehicles are flying every time. So that means it is that will be a very heavy loss if it is not banked. A lot of wear and tear will take place, and also a lot of fuel consumption because of the gear exchange. This to avoid this one, heavy roads at the curved parts are banked. So now I am drawing a banked road here, right? So this is a curved road, right? This is the level part, and this is what is called the level part, making an angle theta here. So a car is coming, and a car, I am making a car, simple car. Yes, okay. This is the tires, right? This is a simple car I am making like this. Okay, this is the condition. A car is negotiating a curved road that is banked at that particular point. Banking angle is equal to theta, right? Okay. Now you see, if the car is moving in a circular path, naturally it has a tendency to move outwards from the circular path. Therefore, force of friction. I am writing force of friction like this along the inclined plane like this. This is the force of friction. Force of friction is that must be parallel to the plane on which it is parallel to the plane, right? This must be parallel. This and this must be parallel. This is what's called force of friction, right? The other force is what's called mg. Mg is acting vertically downwards here. Mg is acting vertically downwards, right? And R is acting perpendicular to the plane. This is R. R means normal reaction. Normal reaction is always perpendicular to the plane on which it is, all right? R can resolve two components. One is this one. That is exactly true mg. This also theta only, right? Then naturally that will be equal to R cos theta. This is R, this is R cos theta, right? Okay. Next is R cos theta. And this R can resolve two components. One part is R cos theta, other part is R sin theta. R sin theta I am drawing like this. This is what is called R sin theta, right? Okay. Now F also can resolve two components. Suppose if this angle is theta, naturally this also will be theta. Therefore, F can be resolved two components. This is F cos theta. F cos theta is acting like this, and the other one is F sin theta is acting like this. F sin theta. So this resolution is very important, right? This is the diagram very clear, I suppose. The banking angle is equal to theta, right? Okay. Mg is acting vertically downwards, and the force, reaction force is always normal reaction. It is called normal reaction is normal to the surface on which the body is kept. So if this line is drawn here, that will surely make an angle 90 degree of the surface, because this is inclined surface. This will be 90 degree. R can be at the first resolve two components. One is R cos theta and other is R sin theta. Between these two, the angle must be 90 degree. R cos theta and R sin theta, the angle must be 90 degree. Okay. Then force of friction is acting on the surface. Force of friction is friction between the tire and the ground. That is along this direction. Therefore, parallel to the ground, force of friction must be always parallel to the ground. F. F also can be resolved into two components. One component to make an angle theta, that is along the same direction only. That is what you call F sin the R sin theta direction. The direction of R sin theta only, F sin theta is also acting. And the other component of F sin theta is acting along the direction in which the weight of the car is acting, that is mg. So mg and